File and fit angular mating surface within an accuracy of plus or minus 0.02 mm and 10 minutes angular fitting.
Hi, my name is Deepthi. Filing and fitting an angular mating surface is a process used to ensure that the mating surfaces fit together perfectly. It involves using a file to remove material from the surface and then fitting the surfaces together to ensure a tight and accurate fit. In this video, we will be seeing about file and fit angular mating surface within an accuracy of plus or minus 0.02 mm and 10 minutes angular fitting. Come, let's go into the video.
At the end of this demonstration, you will be able to mark angular outlines of part 1, 2, 3 with an accuracy of plus or minus 10 mm accuracy. File part 1, 2 and 3 maintaining the accuracy of plus or minus 0.02 mm for fitting. Assemble the part 1, 2 and 3. Finish and deburr. Tools required. Steel rule 300 mm. A steel rule is a measuring instrument that is used to take accurate measurements of the length, width and thickness of various components. Scriber. A scriber is a marking tool that is used to make accurate lines on metal surfaces. Punch. A punch is a marking tool that is used to create indentations and other markings on metal surfaces. Ball-peen hammer. A ball-peen hammer is used to shape and form metal components, such as by bending or flattening a piece of metal or by shaping it into a specific form or contour. Hacksaw frame with blade. A hacksaw frame is used along with a blade to cut metals of different sections and is specified by the type and maximum length of the blade that can be fixed. Smooth file, flat, square, triangle. A smooth file is a type of file that has a cutting surface that is much finer than rough or bastard files. It is used for fine shaping, smoothing, and finishing work on metal components after initial roughing out work has been done with coarser files. Flat files are typically used for removing material quickly and efficiently, creating flat or angled surfaces and shaping or smoothing curves or edges. The triangular shape of the file makes it ideal for reaching into tight corners and removing material from hard-to-reach areas. Triangle files are available in a variety of sizes and cuts, which determine the courses of the teeth on the file. Tri-square. A tri-square is a measuring tool used in metalworking to check the accuracy of right angles and to mark straight lines. It is a simple but essential tool for anyone working with metal or other materials. Equipment required. Surface plate or table. Surface plates are used to measure the flatness and precision of other components such as machine parts, tools, and fixtures. They are also used for layout and inspection work where precision and accuracy are critical. Vernier height gauge. A vernier height gauge, also known as a height gauge or a height caliper, is a precision measuring instrument used in metalworking and mechanical engineering to measure the height of objects, and also it's used to make precise marking on the jobs. Angle plate. An angle plate is a work-holding device used in metalworking and machining that is designed to hold and support workpieces at a precise angle to perform marking function using tools like vernier height gauge. Bench vise. A bench vise is a work-holding device that is mounted on a workbench or table and is used to hold a workpiece firmly in place during machining, cutting, filing, drilling, or other work. Vernier caliper. A vernier caliper is a precision measuring tool used in metalworking and mechanical engineering to measure the internal and external dimensions of objects as well as the depth and step measurements. Vernier bevel protractor. A vernier bevel protractor is a precision measuring tool used to measure angles with a high degree of accuracy. The tool consists of a base, a blade, and a vernier scale. The base is flat and typically made of steel, while the blade is attached to the base and can be rotated to measure angles. Before starting job, there are some preliminary checks to be made. These are as follows. The first check to be made is raw material check. Check the raw materials for its size. Next, we are going to file all the parts. File the surface to its overall sizes for flatness and squareness. Next, we are going to mark the dimension for making holes in all the parts. Mark the dimension and location as per drawing on part 1 by using vernier bevel protractor. Mark the dimension and location as per drawing on part 2 by using vernier bevel protractor. Mark the dimension and location as per drawing on part 3 by using vernier bevel protractor. Now, we are going to punch witness marks in all the parts. Punch on the location of marked lines on part 1 using center punch. Punch on the location of marked lines on part 2 using center punch. Punch on the location of marked lines on part 3 using center punch. Remove excess materials by hacksawing. File the parts to its size and shape. File to size and shape in part 1, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. File to size and shape in part 2, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. File to size and shape in part 3, maintaining an accuracy plus or minus 0.02 mm and angular of 10 minutes. Now, let's begin the process. Check the linear dimensions with vernier caliper and angular by vernier bevel protractor. Fit part 1, 2 and 3 simultaneously and finish. Apply little oil for preservation and evaluation. Note: do not mark angular dimension or angle by scale or set square while marking. Do not make a force fit.
Let's have a recap of what we have learned today. We have learned to mark angular outlines of part 1, 2, 3 within an accuracy of 10 minutes. File part 1, 2, 3 maintaining an accuracy of plus or minus 0.02 mm for fitting. Assemble the part 1, 2 and 3, finish and deburr. Thus, we have learned to file and fit angular mating surface within an accuracy of plus or minus 0.02 mm and 10 minutes angular fitting. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.